Hello, everyone, and welcome to this workshop. Glad to see people are joining us. We will be starting in a few, just waiting for a few people, and then we can get started with our workshop for today. Please let me know in the chat if you can hear me right and if you can see the slides clearly. Hello, Jean. Hello, Akash. Hello, Irina. Sundar, hi. Yes, thank you. Cool. Yuri, welcome. Yuha, Alba, Behzad, welcome everyone. We are going to start in a minute now. Just waiting for more people. Humaira, hello. Maria, hello. Hi. Olga, I see a lot of people. Hello, guys. Happy to see you here. All right, cool. Thanks. Okay. Starting in a few seconds now. Okay, cool. I think we can get started. Again, welcome everyone. Thank you for being here. Today, this is a new workshop brought to you by Code Labs Academy. The workshop title is Introduction to Machine Learning. And to get started, I'm going to present myself. I am Riyad bin Sanem. I am a CLA instructor. So I am an instructor at Code Labs Academy. I work as an IT consultant and I have a data science background. And my job really and my passion is to help data scientists in the making and help people get into this field, interesting field, and help them grow their knowledge, their skills, and why not become a great data scientist, right? So this is me again, Riyad bin Salim. If you want to get in touch with me, you can have here my email address. So just before starting to talk about like the subject of our workshop, if you can check, you would have a besides the chat tab, you have polls tab where you can answer the questions. So there is a couple questions that they are interesting that we need to answer before we start. So the first one, do you have an idea about machine learning? ML for machine learning. So do you know what is machine learning? And also, I would like to know, what do you expect from this workshop? At the end of this workshop, do you think that you will become a super machine learning engineer? Do you want to conquer the world using AI? Or maybe you are here just to get started with your journey with machine learning, or to understand what is these new topics that everyone seems to talk about and to be interested in? Okay, I already see some answers, and I think you can see the answers also because it's public. So waiting for more people to answer. So yes, guys, again, people who joined us, welcome. And you can check in the tab next to the chat, you can find polls. You will find two questions. Please answer them. Yes, thank you. I already see people answering. Thank you, guys. Okay. All right. So, do you have an idea about machine learning? I see that some of you already do, which is good. Some people are not really sure or if they know about machine learning, which is cool also. And some other people they don't really know what is machine learning, which is also cool. This is why we are here. And what do you expect at the end of this workshop? To become a super ML engineer, hopefully, why not? Conquer the world. Oh my God, we have some word domination ideas happening here. and to be able to start my journey in machine learning. Hopefully, we can help you with this. And I can see also people answering to understand what is ML about. Okay, cool, very cool. Okay, so we can get started now. And first, let's present to you what we are doing from this workshop or what to expect from this workshop. So today we are going to talk about machine learning. We are going to understand where people are using machine learning, what is machine learning actually. We're gonna see the difference between AI, machine learning, deep learning, and all these confusing terms. We're gonna talk just a little bit about the history of machine learning. We are going to talk about some ML approaches to give you an idea about the landscape and what people are doing in machine learning actually. We're going to talk about the component of machine learning algorithms. So you will have the breaks, the small breaks that will allow you to build knowledge around machine learning. Sorry, and of course we are going to code a bit. So it won't be only boring talking, but we are going to see some code, which I think it's very interesting to see things happening. And also at the end, some surprise for you. You will see some what is new in machine learning, and I bet you will be surprised. I think you can prove me right after that. So, waiting for that, let's get started. Okay, so we're going to start with what is the applications of machine learning and where people are tend to use machine learning. So this is a quick, just to give you a sense of what's happening. For instance, here, machine learning could be used on object recognition. So when you see people talking about object recognition, when you see people trying to detect objects existing in images and even videos, we are talking about machine learning. As you can see here, we can detect dogs, cats, person, animals, different animals, and vehicles, etc. So this is one of the cool applications of machine learning. A second application would be recommendation system. I think many of you have used Spotify on Netflix before, right? And if you have used them, you will see that sometimes these tools and these applications or these softwares recommend either music, either movies to you. So how do they do that? Well, they do that using machine learning. Another application of machine learning would be translation between languages. So very popular tools like Google Translate or DeepL are powered by deep learning and machine learning in general. So again, another cool way to use machine learning. And one of the latest domain of application are self-driving cars with Tesla, etc. You see that cars can drive themselves, and this is powered again using machine learning and AI in general. All right. So I'm gonna ask you another question now in the poll, if you don't mind. So I'm gonna add the question just now. Here it is, sharing now. Okay. I'm sharing another question. So now after you have seen these tools and you have seen where we can use machine learning, do you think you have used these products before or any other products that might use machine learning? Yeah, so just think again about what we have seen of domains of application, self-driving car, recommendation systems, image recognition or object recognition in images, translation, Google Translate. So anything you use actually, or a lot of software you are using, are actually powered by machine learning, which is very interesting, which means that it's everywhere and it's in your interest to get to know this new domain. And also, uh, maybe remove some false ideas around the topic. All right, I see that most of you have already used these tools, which is cool. Now we are going to talk about how can we use machine learning and what is this magical, let's say, tool that allow us to have these cool products. All right, moving on. And please, again, as a reminder, if you have any question, please feel free to ask, tag me in the chat, and just ask the question. here to answer all your questions. So now we know what is the domains of application of machine learning. So now what is machine learning actually? So as Arthur Samuel already said, machine learning enables computers to perform tasks without being explicitly programmed to do so. So as you know, you can program different many softwares, right, to do different tasks. But the difference when using machine learning is now we don't want know actually what is the task explicitly, or we are not programming the software to do it explicitly with all the steps, but we are letting the machine learn and do the task in a better way if the machine can achieve it. So basically, this is a global idea of what is machine learning. And let's take an example here. Maybe it will give you a better understanding. So we are talking here about tasks and doing tasks. So before, we can see an analogy maybe between before machine learning and then after or using machine learning. So without using machine learning, when we build solutions, we specify all the possible scenarios, right? So I'm building up any product. I'm gonna think of my customer, how my customer will use the product, for instance, how my program will answer the need and the task. So I need to think of all the scenarios and then program the computer to interact with these scenarios that it will encounter. And at the end, the computer will be able to complete the task because he has every scenario possible programmed in it, right? So this was before machine learning. But now with machine learning, you don't really need to think about every possible scenario, which is sometimes impossible. So we can here provide an information to the computer, and then the computer will learn from that information, and then after learning, the computer will encounter so different and many scenarios. But now the computer, even though he didn't see the scenario before, he is able to take decisions and he is able to complete the task. So basically, this is the difference with using ML and without using machine learning. All right. Is it clear, guys? You have questions? Please feel free in the chat. If you have any question, clear. Cool. Thanks. Thanks. All right. No question from Yuri. Thanks, guys. Cool. So I see that new people are joining us now. Welcome. We are just talking about what is machine learning and what is the difference between using machine learning and not using machine learning. Okay, moving on. So the domain of machine learning actually could be seen as the intersection of different domains, right? So if you know about statistics and probability, and if you know about linear algebra, calculus, software engineering, optimization, and also databases, you are now set to get started with machine learning or to understand the concepts. I know it might seem scary to have knowledge from different domains, but it's doable. With the right approach of learning and with the right people to help you, you can do it. You just need to learn the essential things know what to learn actually from each domain. But machine learning is actually the intersection of all these domains. So you will find some math from your university, from your high school. You will need some concepts around software engineering, building code and building software. You will need to learn about optimization because this is what we will do in machine learning. And you will use databases and you will use data. So we are talking about data here. So we will use also databases. So basically, this is the domains that are around machine learning, let's say. Okay. Okay, so before that, let me ask you another question in the poll, right? I want to hear from you guys. I'm going to add another question now and share it. So again, in the polls, you have the chat tab, you have the polls tab, click there, go there, sorry, and then see the questions we have. So the last question I just added is, Do you know what is the difference now between AI, machine learning, and deep learning? So I'm pretty sure that you have heard these terms before, but it might be a bit difficult or confusing to use the term. So people talk about artificial intelligence. Is it the same as machine learning? And what is this new thing of deep learning? Does it mean that we are doing learning but in a deeper way? We're gonna see, right? All right, I'm seeing some answers, which is cool. All right, so I think most of you guys are not really sure about how to distinguish between AI, machine learning, and deep learning, which is okay. Here we are here to answer different questions, right? Let's do this. Okay, so what is the difference? So, first of all, the big domain is artificial intelligence, and the other two domains, sorry, are part of it. So, AI or artificial intelligence is where we try to perform tasks commonly associated with intelligent being. So, for instance, let me give you some examples. We perceive things, right? We see things, but we perceive them also. So, when we see an apple, we understand that this is food, right? And we understand the shape, the color of the apple. And we understand that the apple is put on the table. And we understand if we move the apple, from the table, it will fall on the ground, right? So there is a lot of processing happening inside your brain instantly and without noticing it, allowing you to understand the world around you, right? And artificial intelligence comes to trying to mimic these capabilities that we have as humans of problem solving, of perceiving things around us. So this domain tries to mimic this and give these capacities, awesome capacities, to the machine. So the machine can perform tasks as well as we do, or maybe even better. Who knows? But not. So this is generally artificial intelligence. And the machine learning now is a subdomain of AI. All right. So in the machine learning, we perform tasks without being explicitly programmed to do that. This is the definition of machine learning. So we are in artificial intelligence domain. We are trying to make the machine learn things as or mimic our intelligence. And one way of doing it is going into machine learning by trying to give this capacity to the machine to learn and to do stuff without programming it explicitly. All right. And this is AI and machine learning. Okay, so I see a question. So an AI can be programmed instead of thought? Not exactly. So, but yeah. So there is a lot of domains inside AI, rather than machine learning, which includes some programming, but not only. But yeah, you can say that it's true, but it's partially true. It's not the full truth. Yeah. So again, getting back to the explanation. So now you know what is AI. You're most welcome. You know what is AI. You know what is machine learning. And now let's talk about deep learning. So again, deep learning now is a subdomain of machine learning, which is learning techniques, some techniques that are used, some learning techniques that are used inside machine learning. So basically, deep learning is based on neurons. So you might have heard of this before. So deep learning uses a neuron architecture, so a neural network, a network of different neurons that communicates with each other and will allow us to do really cool stuff. So again, we have artificial intelligence, we have a subdomain which is machine learning, and another subdomain of machine learning which is deep learning. Hopefully now you have a clear idea about what's happening, right? So now I think if we ask you again the same question I sent you, the response will be totally different. Most of you will know what is the difference between AI, machine learning, and deep learning, hopefully. So if you have questions, also feel free to ask. All right? Cool. Let's move on now. So I will give you a quick recap of what happens in machine learning just to understand the full, or to get the full image, the whole story of machine learning. So starting from 1950, statistical methods were discovered. So a lot of probabilistic and statistical method were starting around 1950 or and before that, and that this is the groundwork of machine learning. And then after that, in the 1960, 59, let's say, we have the term of machine learning appearing, which is, as we said before, allowing the machine to learn stuff without programming it explicitly. So the terms appears. And in 1960, we have methods that we are called Bayesian methods that were introduced, so that are like really used now in many machine learning models. And in 1970, there is an era where we call it AI winter, because not much funding was directed towards AI. We didn't have much interest in this domain in the 1970s. So it was a bit cold for AI at that time, at that period. But in the 1980s, people are now gaining interest again in the domain because we have much better CPUs at that point in history. And then in the 1990, we are shifting towards data-driven research. So we are focusing more about having a large amount of data and trying to explore the data, apply some statistic on it, try to get some insights from the data, which really helps, which is the core actually of machine learning, and helps in boosting machine learning. And around 2000, so we had machine learning methods become like widespread. So people now are more familiar with machine learning, trying to use it, trying to apply it, and advance the domain, right? And around 2010, which is, let's say, recently, we have deep learning appeared. And deep learning allowed us to do a lot of cool stuff regarding to image processing, in regards to even machine translation from one language to another language. We use deep learning for that, and a lot of other tasks that we are using right now. So deep learning really helped boosting things up. All right. So this is just to give you a history of what happened. Again, let me remind you that we are going to see some major concepts in machine learning, and then we are going to see some code, of course. Are going to program one machine learning model or method, and we are going to understand that. And at the end, again, as a reminder, we are going to see what's new and what's cool in machine learning. So let's continue, and don't forget to ask question. Okay, so now let's talk about more details about what is machine learning and the approaches we have inside machine learning. So in machine learning, we are in face of three major approaches. We have the supervised learning, we have the unsupervised learning, and we have what we call reinforcement learning, right? So again, supervised, and reinforcement learning. Let's explore these. Let's start with the first one, which is supervised learning. So here we are going to take a use case, and we are trying to understand these approaches using that use case. So our interest, let's say, I'm a cat lover person, right? So I like to talk about cats. And I am also concerned about my cat's health. So I want to know if my cat is fat or not fat. All right. So in order to do that, I collected some information. And the information I'm talking about is the age of the cat and the weight of the cat. So based on these two information that I have, or this is the data that I have, I started to label, what we call labeling my data. So for each case individually, I go to the cat, I see it, I see that I know the age, I know the weight, and I know if the cat is fat or not. So I tag it or label it not fat for the first use case here. The second use case also, I got the age, I got the weight, and it's also not fat. And for the third case, I have the age again, 1 year, 3 kilograms, and this cat is fat. Okay, and I do the same for multiple times to build what we call a data set, right? So now we have a data set containing information or features, and here the features are the age and the weight. And I have the labels, and the labels here is either fat or not fat. So this is a typical case of supervised learning. So actually what I want to do here, I want to build a model that when I give it information about a cat, especially my cat, yeah, probably chunky, yeah. What I want to do is to build a model that will allow me to, based on the data collected about a cat, specific cat, tell me if it's fat, if it's not fat, or is it chunky, right? All right. So this is what we call a categorical or a classification case. So now I'm doing classifications over my data to classify it in one of two categories. Or it could be many other categories, not necessarily two, but here we are talking about binary classification, which means we have two categories in a classification use case. And the labels, we call the labels here categorical, which means that the labels have a certain discrete number of values. For instance, here we have two values, either fat or not fat, right? This is categorical. And this is a case of classification, which is under supervised learning. Another case under the same supervised learning, we call it regression. So in regression, we are not trying to get a class. Our model is trying to predict a number, a continuous number. For instance, let's say I want to predict the waist size of my cat, maybe, or even the length of my cat. Here we have examples for 23 centimeters and 26 centimeters. So basically, I want to build a model that give me as a result, not a class, but give me a number, right? And this is what we call a regression. So again, we said that there is multiple approaches for machine learning. One of them is supervised learning. And inside supervised learning, what do we have? Can anyone answer? What do we have? In the chat, maybe? All right, I'm waiting. We have categories, right? And we call it classifications. Really good. And we have another thing, regression. Yes, what we are seeing. Exactly. So we have two cases, classification and regression. Cool. We have another concept here. When we talk about supervised learning, we are talking about training our model on labeled data. So as I explained before, I said that I have a question. What are regressions? So regressions is, as I explained, is the case where my predicted value is not a class, is not a category, but a number, a continuous number. For instance, I'm going to give you an example, which is a very known example in machine learning. If we want to predict the price of a house based on some features, that value price is not categorical, right? It's not a price, let's say expensive or not expensive. I want to have the exact price. So this is a number. This is not a class or category. This is a use case that we call regression, trying to build a model that do a regression to give us as a result a continuous number. Right? Is it clear? All right, cool. Marketer's question. Okay. All right. Let me continue. Yeah, I was talking about the data and training. So in supervised learning, we said that we have data or features describing something, and we have labels that comes with this kind of with our data, with our features. So the labels are actually trying to see and know if it's like, for instance, here, not fat, not fat. Okay, and so we have this aspect of training the model over data. But what we want actually is to be able to also test the model. So what we do, we take the data set, we split it into training data set and test data set. This is one example. So for instance, we can take 80% of my data or my data set. I will take it into training, give it to the model. Here we go. Try to train and understand if the cat is fat or not. And I'm gonna take a proportion, the 20%, and leave it apart. So after the training, I can test my model on those test data or test data set. This will give me metrics to tell me if my model is good or not. All right. So here we are talking about metrics that tell me the performance of my model. So basically, in supervised learning, we have labeled data and we split the data set between training and test. Okay. So we have another question in the chat, which is percentage also part of regression or only exact numbers? Yeah, good. So it depends on your use case. If you have really specific values for the percentage, let's say you know that in your data you will have only like 20%, 50%, and then 100%. Then here you are doing categories. But if it's not, if it can be inside the range from 0 to 100, then now you are talking about regression, right? So if you have a specific number of values that you can get, you are talking about classification. If not, regression. Is it clear? Cool. I'm just gonna mark this as answer also. Cool. All right, so let's move on now. Now we are going to talk about a second type of or approach in machine learning. We talked about supervised. Now let's talk about unsupervised learning, right? So in the unsupervised learning, the difference here is that we don't have labels for our data. So my cat, I don't have a chunky cat or a not fat cat, right? I don't have that. So this is a whole new era, a whole new domain. How can we do this? Let's see an example. So for instance, here again, I have features related to different animals, right? And the features I have are either the animal has fins or the animal has wings, right? I have multiple animals and some fish, some birds and fishes. So now I know that I know the values for each type of animal, but I don't have really a label here. So one example of unsupervised learning or unsupervised learning model is it will try to what we call cluster. All right, cluster or create groups of data. So it will group the birds and it will group the fish. And so the model here is trying to understand the patterns inside the data without any external help from the labels, let's say. So we don't have labels. We don't. This is clustering, grouping, is clustering. Yeah. So clustering and grouping are pretty much the same thing. We are trying to group elements in our data set into different groups that have similar features. So this is basically what is clustering. And also, so the model here doesn't have like labels to rely on to try to know what's happening, right? So it will try to just see the similarities inside the data itself and create groups, different groups of elements in our data set, and say like you have this is group one, this is group two, this is birds, and this is fish. So this is an example of unsupervised learning. Okay, so we have seen supervised learning, we have seen unsupervised learning, and now we are going to talk about reinforcement learning. Okay, so reinforcement learning is another approach where we can call it a robot, we can call it, but the appropriate term is agent. So an agent exists in an environment, right? And the agent will take decisions. If it takes the bad decision, I'm gonna abstract points from the agent. If the agent takes a good decision, so the agent will get some extra points. So doing this system of reward and punishment will teach the agent to behave in a certain way that I found that it will help me solve my problem. This is just like training your dog, right? If the dog, you throw the ball to the dog and the dog gets it, you give it a treat, right? So you are giving a reward on that good behavior, and you might like scream at your dog if he is doing some bad thing, and this is considered punishment, right? Yes, just like a child. Yep. So you given a reward, you given punishment, and this will allow the model to, or the agent, sorry, to learn how to behave in an environment. And this is really used a lot in finance, where they try to build an agent that understands how, and let's say how the stock is growing or decreasing, and try to predict that, and then it will help them to predict the future values. So this is also a very cool way of applying things. And even the self-driving car, is a good example here. Not totally only reinforcement learning, but also we are trying to teach the car to not hit the pedestrian, right? And we give it a reward for not doing that. So reinforcement learning is used in robotics. So it is used in robotics actually, but not only. Explaining it in this way give it a more clear sense. But yeah, it is used, but not only. Okay, so now we have seen the three major approaches inside machine learning. Again, we have supervised, unsupervised, and reinforcement learning. All right, moving on now. Now we are going to talk about the main components of machine learning. So the main component of a machine learning algorithm are tasks, the task we want to do or we want to model to perform, do a classification, do an object detection in an image, self-driving car, drive, for instance. But like this is abstract. But yeah, so we have multiple tasks. So this is the task, and we have the structure of the model, which can be different from which type of model we are using. We have the objective function. So basically, the objective function is a function that the model is using to either to maximize or minimize. So if we are talking about loss, let's say, we want to minimize the loss, right? So this is a function that we want to minimize, and minimizing this function will give us good performance for our model. And we have an optimization method, or optimization. We have multiple optimization methods, and this will help us optimize our solution or arrive to the appropriate maximum or minimum for the objective function. Basically, this is the main components, and we are going to see an example to understand. So just abstractly to talk about the main concepts, like in general, we have the task, right? We have the structure of the model. We have the objective function that we either want to maximize or minimize, depending on the case. And we have also the optimization method. And in order to understand better these concepts, we will take an example, right? We are now approaching the interesting part where we are actually going to learn something about machine learning model. So for today, we are going to talk about logistic regression. And we are going to talk about the task of the logistic regression, the structure of the model, the objective function, and the optimization method. So for logistic regression, we have a task of classification. Okay, So where are we now? We are in supervised learning. So now we can understand that logistic regression is a supervised learning method, and it's a classification method. Okay, the classification or the classes or the categories could be binary or more than just two. So we can have just two classes, binary classification, or we can have multinomial logistic regression for classification with multiple classes. For instance, I don't know, if I'm trying to predict the weather could be cloudy, windy, it could be sunny, um, rainy. We could have snow. So we have multiple categories, right? So not just two. So this is for the task. For the structure, we are going to talk about that in a few. The objective function, we call it here the binary cross entropy. So you will hear this when you are in a classification or binary classification use case. You will hear this a lot. So remember, we have binary cross entropy. The binary cross entropy is a function that we want to minimize, that will help us to find the minimum error that will make our model good. We are going to talk in detail about these, don't worry. We have also the optimization method, which is the gradient descent, which is an optimization method. Okay, let's go and talk about more in details about these. So let's talk first about our data, right? So we have a data set of chunky or fat cats and not that much fat cats. This is the data set we are going to use with our logistic regression model, right? Used for binary classification. Again, so I know that some of you might be confused because we said before that regression is not for classification, and this is for continuous numbers, right? But here, this is not just regression, this is logistic regression. So logistic regression is used for binary classification, okay? Hopefully it's not really confusing for you. Okay, moving on. So we have the data set, right? And let's take one example. So we have this first cat, and this cat, I know it's not fat, right? So it's not fat, and this is, sorry, the values I have for it. So I have the age and I have the weight, as we have seen before, right? What I'm going to do for this logistic regression, the logistic regression will take the features, age and weight, and multiply those by something we call weight. So we have weights that will be multiplied by the features. So for instance here, I'm going to multiply age by 0.5, and I'm going to multiply the weight, which is 2, by 1.2. And then I'm going to add. So this is for people who are already familiar with matrices. This is a multiplication of matrices, right? So I'm going to take the age multiplied by the first weight, 0.5. I'm going to take the second weight, which is 2, multiplied by 1.2, and then do the sum of these two multiplications. This will give me 2.9. Again, this is just an example. So the first step of logistic regression is to take the features and apply some weights over your features. And after applying your weights, we have what we call a bias. We add a bias. So this is the second part of the structure of logistic regression. First, we have weights, and then we have bias. And the bias is added to the result of the first multiplication. So we have 2.9, and we add 0.2, and the result is 3.1. Okay, so again, we multiply the features by the weight, we add the bias to them, and we get the result. And then this result will be passed through a function. This function is called an activation function. And we have multiple types of activation functions. But in the logistic regression, we use what we call a sigmoid function. So a sigmoid function takes as an input the result of our multiplication and addition, do some transformation on it, and give us a result. Now let's take a step back, right? Let's take a step back and try to understand what's happening here. So I have my data. I have my data set containing cats, fat, not fat. And actually, in my data set, when I was trying to label each row or each cat for each cat, I didn't use actually the word fat and not fat, but I actually used 0 and 1. So if the cat is not fat, I'm using 0. If it's fat, I'm using 1. Okay, so 1 is for fat, 0 for not fat. Because why? Because the models works better with numbers and not just words, right? So I'm mapping the words into numbers. So this is taking a step back. And then the logistic regression will take the features and not the label, not yet, just the features, apply some weight, add the bias, and call some weird function, and give us a result. Right. So what this weird function is doing, actually, it takes the result and give us a number between 0 and 1. So the sigmoid function actually give us whatever you give it as an input, it will give you a value between 0 and 1. And this is actually what we are seeing here. After applying the sigmoid, we have a value of 0.95, right? So this is a value between 0 and 1. Now, I have a value between 0 and 1, but how do I know if this is fat or not fat, right? So actually, we have a threshold, which is 0.5. So any number more than 0.5, I will consider it as 1 or class 1, which means fat. Every number below 0.5, between 0 and 0.5, will be considered 0, which is class 0, which is not fat. Okay? So actually this function, this weird function called sigmoid, tries to push everything in input between the interval of 0 and 1 and give me some value that I will compare with 0.5. And then it will give me either class 0 or class 1. For instance here, the class that we have is fat. So we have 1 as class. Okay, we have a question. Let me check the question before moving on. Okay, how do you pick the numbers for the weights? Actually, this is a very, very, very interesting question. Thank you for asking that, Angela. So, Angela is asking, how do you pick the numbers for the weights and biases? This is the sense or the core sense of machine learning. It's all about finding the right weight and bias. So all what we are going to do and all what we are seeing is just to try to find the right weight and the right bias that give us the right result. Okay, I'm gonna give more details about that. So actually, now since I have a result of fat, the cat is fat, but actually the cat here is not fat. All right, so my model is wrong. How can I change this to make my model do the right prediction? I actually can do that. And this is what we call learning. This is related to Angela's question. We are trying to adjust the weights and the biases in order to have the right result, which means that after having the new weight and the new bias, I should get the right value that gives me the right class. Okay, so all the work is about this. So now, before going to talk about how can we get the weights and biases, do you have questions? Sorry. Before talking about how we get these, do you have questions about what you have seen so far? About the model, anything? Okay, we have a question. The question is, the right result is dependent on what? Is there already a known output? Actually, yeah, there is an output. Uh, as we were explaining, here we are in the labeled, we have labeled data. So we are in a supervised learning use case. So I already know that the cat is fat or not. And this is the training phase. So this is the training phase. And in the training phase, I give the model the features that I know what is the label and what is the result and try to update on that. Okay, cool. Finish answering. Okay, I have another question. Could you please say again what is B? So B is bias. It's called bias. And this is a constant value that we add to the multiplication of my feature with the weights. So I multiply my features with the weight and I add the bias to it. Okay. Finished. Okay. I have another question. Both the weights seem to increase the likelihood of being fat. Can we have a negative weight? And maybe if the cat is older, it would be more frail and less fat. So then make the weight for the age negative. Okay, this is very good. This is very good. Trying to think in this way. Actually, we are trying to find the best weights. I'm gonna see how we can do that. It could be negative value, but you should take in consideration that we don't have only that one example. We have many examples in our data set, and we should find the weight that will give us overall a good result. So it's not really specific to one case, but really to many cases. But yeah, this is good thinking, but this thinking would be done by the model and the method we are going to explain and not by us. So let me now move on to the next point in the presentation, which is how to find the weights and the biases. So actually, when we have a result, we have, as I explained to you before, we have what we call a function called binary cross entropy. And actually, this function, we give it the prediction of our model. As for example, we have seen that our model predicted that it's fat while it's not. So this is the prediction of our model, and we give it also the right and appropriate labels, right, Mary? We give it the right example, and then after giving it the right example and the predicted one, this function will help us compute a cost which is basically a difference between what is predicted and what is supposed to be predicted. And this cost function, which is in our case called binary cross entropy, we will try to minimize. So this function represents the error value of our model, and we are trying to minimize this function, right? So to minimize this function, we will apply what we call a gradient descent. Unfortunately, we don't have much time to explain gradient descent in our session, but just generally, gradient descent is a technique and that will allow you to find the minimum of a function, right? And this is what we want. We want to find the minimum of cross entropy. And after finding the gradient descent, we will have this formula that you see here, which is not really that complicated. What it will do, it will compute the new weights. So for instance, this data here represent either the weight or the bias, one of them. And we will update that weight using this formula. So we will take the old weight that is not really good, we'll subtract from it this value. And this value, actually, we get it from the gradient descent technique multiplied by this alpha. So alpha, maybe you have heard of this. This is what we call the learning rate. So the learning rate will be multiplied by the result of gradient descent, and this would be subtracted from our weight. And this is how we update the weight. Following this technique, this formula, and applying it multiple times, based on the result of the cross entropy function, the function we want to minimize, will push us towards the appropriate weights and give us the good weights that give us good performance. So this is how we compute weights in logistic regression. So in logistic regression, we compute weights using this formula. So we have the function, we try to minimize, we apply some techniques, we update the weights, and we get a better result. Okay? So this is actually the summary. So we have, and this is exactly what I was saying, just having our model predict something, compute the cost function, and then use gradient descent to optimize the parameters, and then do the learning again until we have some good weights. Okay, some of you, okay, Joseph, we still have a lot of interesting things to cover. Hopefully, you have learned something before going. Yeah, we have a recording of the session. Yes, we have the recording, I guess. Yeah. So let's go and see some practical aspects now. Okay, let me reshare my screen. You are welcome. Okay, guys. Now we are doing some cool stuff. We're gonna see some code, and I'm gonna go quickly over the some things. But basically, you can do what we have explained. You can do it using some Python libraries that will take all the complexity from your hand. So I'm gonna start by importing some Python libraries. Hopefully, you are a bit familiar with Python. So there is, for instance, pandas, NumPy, Seaborn for visualizations, and more. And we're gonna see how we are going to use this. So the example I chose here is and a bit of different than chunky and not so fat cat. We are here talking about the diabetes, right? So this in this data set that I'm loading now, I'm gonna load here, and I'm gonna see some entries. So this is my data set. I have multiple features as we saw for the cat. For the cat, we saw the age and the weight. Here we have much more. And here we are trying to predict if someone will have or has diabetes or not, right? So this is the outcome, which is the class. Either 1 or 0 for having diabetes or not having diabetes. And we have multiple features that allow us to do this prediction. So now we are in a more serious use case, right? We can have some visualizations to understand our data. For instance, here, I'm using Seaborn, which is a Python library that built this visualization, and it will tell me that I have, for instance, 500 data points from class 0, and I have about 300 from class 1. So I know how much I have in my data set from people who have diabetes and don't have diabetes, right? And we can have other figures which are cool. So here we can see the distribution, let's say, of one of the features. So this feature, diabetes pedigree function, sorry for pronouncing it like that. So this actually feature means this is a way to try to see if a patient is more likely to have diabetes or not. And we are trying to see the distribution of the values of this feature. So again, here, this is my data set, and this is one of my features. And I'm trying to understand this feature and see how the values of these features are distributed in my data set. So this is basically one of the steps of trying to understand your data set before trying to work and build your actual model, right? Which is very, very important, again. Also, we can have some cool visualization using also Plotly, which is another tool, another Python library. Actually, here what you see is a bubble graph where the color refers to a person if the person has diabetes in yellow, or in blue person doesn't have diabetes. And also the size of the bubble, of each bubble, represents the likelihood of having diabetes. So you can see, for instance, some cool stuff here. Between the age of 20 and 30, this function that tells us that you are more likely to have diabetes, then you probably have diabetes. And if you're less likely to have diabetes, and then you can see that there is a lot of people here that don't have diabetes. And also, this is related to the BMI, body mass index. So this is a fraction between your weight and how much tall you are. And so you can see multiple information in one graph, which is also cool. And actually, in Code Labs Academy, we have courses to teach you how to build these kind of cool visualizations and how to understand the data before getting into the model. All right. And if you remember, I also talked about splitting the data between training and testing. So this is what I'm doing in these lines. I'm splitting the data here, train and test. And actually, this is an example from what we do in Code Labs Academy. We do for this specific use case, we implement logistic regression from scratch. I mean, we implement the math behind it. We help you to understand it and create the Python code that will implement that math. And you can build your own model and not rely on some Python libraries. So you will have a really good understanding. But unfortunately, we are not able to add it here in this short like workshop. So I'm gonna jump right into using sklearn, which is a very popular machine learning library that will help you build the logistic regression. So what you're gonna do is actually just call it, right? So it's already there, already prepared. You just call it. So from sklearn, linear models, get me the logistic regression. Okay. And actually what we are doing here, we are calling logistic regression and building our model. And we are the fit function actually is the function that it is actually training. So when you call it fit, it means that you are training your model. And you give it your training data and your training labels again. And after training the model, you will do some prediction just by calling model.predict, that easy, and get your predictions. And then you can see the score here. So this is accuracy score. This is one of many scores that will allow you to understand how your machine learning model works. And for instance, here we have an 82%. So 0.82 is an 82% precision. So our model is precise or accurate to 82%, which is very cool. In order to predict someone if he's has diabetes or not. And if you can notice that the scores I'm computing not on the training data set, but on the test data set here. So I'm calling the prediction over the test data set. Let me check if you have any questions. No questions. Okay. Okay. So again, building a logistic regression. And then after having the result, we can also build some other visualizations that are really cool. Let me show you. It's gonna run this and run this. Okay. So for instance, this will show you for each case or each person, if the red is what we have predicted as negative, you don't have diabetes, and the 1 is what we have predicted as diabetes, right? And then the green is the actual outcome, which is the correct label. Not what we have predicted, but the correct label. So in this graph, for instance, you can see when, for instance, here, I have the green, which means I have a value of 1 for my outcome, which means I have diabetes, and our prediction is mostly blue, which means mostly 1. So probably here we are correct. And here in this second use case, you can see that the mostly is red, which refers to class 0. And I see nothing, which means that the outcome is also 0. So my outcome that I predicted and the actual outcome are pretty much the same in this case also. So our model is pretty much correct here. But again, remember that our model don't really say to you that you are only in class 1 and 0. It says that, of course, but it gives you a percentage of precision. It tells you that you are from class 1, but I'm sure 70%, right? This is why we don't see like 1 on zeros, but values between 1 and 0. Don't worry a lot about this, just to give you an overview of what you can do. And again, this workshop is an introduction to machine learning. It will help you to get into the field, understand the global image, and to see that it is really easy to get started if you have the right people to guide you. So yeah, so this is an example, and this is another example of other plots that we can do. I don't think we have much more time to explain this one, but let me know if you have any questions around what we have seen for the code. We still have some interesting things to see in regards to what's new in machine learning. So, but this was the practical part where we have implemented machine learning model. For some of you, it could be the first machine learning model where we have built the logistic regression, and you can see you can do it in just a few lines of code. Just call in the right library and understand. Of course, you need to understand what's happening under the hood, right? This is why we have the whole course before we try to understand the math just a bit, just to let you know what's happening. But you can see that it's very easy to build a model to do your prediction. Okay? All right, so let me move to another exciting point and conclude with this point. I'm going to stop sharing. I'm going to share again. Okay, what you see here, we are going to talk about what's new in machine learning. So typically now, the big boys playing in the ground of machine learning like Google and the big companies, what they are doing right now, right? So this is one example, the language model Palm. You can Google it, you can find it, which uses a pathways method to learn. And this model actually, this is one model that can do many stuff when adding new parameters. So if you have seen that for logistic regression, we have the weight and the bias, right? And these other methods will actually more parameters you have, more tasks you can do. You can do language understanding. You can do like code completion. You can summarize some text, and you can answer some questions, question answering, and some common sense reasoning, some pattern recognition, doing dialogues. This all can be done by just one model with so many parameters, which is also like, it's crazy. I will give you an example. For instance, this Palm model can answer questions, complex questions, such as if you have, for instance, here, the cafeteria had 23 apples, and then I used 20 to make lunch, and then I bought 6 more. How many apples do I have? So given the model just these kind of like of prompts or a question, the model will actually think like a human and say that, okay, so this is the answer of the model. The cafeteria had 23 apples originally. They used 20. So what they have, 23 minus 20, which is 3. And then they bought 6. And the model understands buying 6 mean 6 more. So doing addition, 3 plus 6 equals to 9. And it will give you the final result, which is awesome, right? What do you think, guys? Another example of what this Palm model can do, it can actually generate some code for you. You can give it the definition of the problem, and it will generate the code. And also it can go from, for instance, translate from C, which is programming language, to Python, which is another programming language. So this is translation inside machine learning models, if you know what I mean. So this is actually also cool. Let me give you an example. There is another type of models really used now and like state of the art, which are text to image generation. So actually you give it a text to a model, and then the model will draw an image in regard to the text. I will give you an example. So here we have this text: a penguin reading a book peacefully while having coffee in the morning. Okay, so just try to imagine this. Imagine a penguin trying to read a book in the morning and like having coffee. You will have an image in your head, and the model can do the same actually. So the model, just given this sentence to the model, and this is the result. So the model draw this from scratch, from just the text, which is awesome. Another example. So a painting of a fox sitting in a field at sunrise in the style of Claude Monet. So Claude Monet is a famous painter, right? So imagine giving this to a machine learning model and trying to see or to what it will do. So for you, take a second, try to imagine how a painting of a fox sitting in a field at a sunrise with this style of Claude Monet could look like. And here's the result. So this is drawn by a model. And so it can understand that there is a style and apply the appropriate style. Let me give you another and maybe final example. It's a bit of a complex now. This is a complex sentence, and let's see how the model will do. So we are in an art gallery displaying Monet's painting again, Monet, the artist. The art gallery is flooded, right? Robots are going around the art gallery using paddle boards. Okay, this is a complex. Yeah. So, and this is more of a complex request, right? So here we have two models. We have Imagine and we have DALL-E 2. So this is two types of models that do text to image generation. And you can see that the models interpreted differently the same sentence, let's say. And actually, yeah, this is paintings, and there you see the museum, you can see the robots, you can see the paddle boards, and you can see how the two models think differently, like as two humans might do, right? Isn't this cool? Would it understand flooded with people or only understand the literal meaning of flooded? So we can see that it can sometimes, yeah, I didn't test it much, but it can sometimes, when you see, it can understand like the concept of flooded and people and combine two. It can do that, yeah. So this is another example of how cool machine learning is now in 2022, right? And what could you do if you like try to focus and learn this domain? Okay, this was like a lot of information, right? And a lot of information, but you can learn more about these topics and with CLA Code Labs Academy. So this is to give you a taste of what we do with our students. We have actually this kind of interactive courses that are done every Saturdays and Wednesdays and Thursdays sometimes, where we are interact with our students, and it's not like just teaching and seeing some videos, but you can ask your questions, try to understand, and we give you examples, and we have this interactive live teaching method that we find that it's really interesting and really helps with people move forward and really rapidly into gathering the knowledge. And we cover a lot of stuff, as you can see. The topics, we have many topics that we cover in the CLA. So yeah, do you have any questions about CLA, about what we have seen today? I'm gonna share with you another thing here. Sharing now. I think now in your left, left bottom corner, you can see a box where you can click on that, and it will take you to a feedback form where you can give us feedback if you like this workshop or not, if you think it's interesting, and especially if you want to get more to get more workshops of this kind. We would be interesting to know that. So please take some time, click on the link, and give us some feedback. We really want to hear from you. And again, please ask questions if you have. We are here to answer your questions, and hopefully you have learned or you have been introduced to machine learning. So at the beginning of the workshop, I have asked you a question, and some of you answered that they want to conquer the world using AI. I don't think that what we have seen today, you will gonna conquer the world, but what you can do is move on and start learning, and we can help you with that. And maybe someday you can do that. I don't know. Just be kind with us, please. De rien, de rien. Merci. Thank you, guys. We share recording session. Yeah, we will have. I think we will have a recording, and we will make sure it will be shared. Yes, yes. I really appreciate this workshop and the interactiveness of the attendees. I really enjoyed presenting it and receiving your questions. So thank you very much. My pleasure to explain this and to present this to you. All right. Do you have any questions? Thank you, Pike. I appreciate. Thank you, guys. Thank you. All right. I can see that half of you have already clicked and are answering the form, which is cool. Thank you. Again, yeah. What would you take? All right. I have a question, which is an interesting question. What would you recommend to continue learning on the matter? Okay. This is a very interesting question. What you can do, how I learned machine learning, is I try to discover first the domain. So try to get a global view of what's happening. And then I try to follow up different online courses to help me move forward, and especially for beginners. And at the same time, I try to do some projects over Kaggle, right? So doing projects on Kaggle will really help you to learn more about the different subjects, and which is really, very important, get practical experience. And for instance, in order to continue learning, one option is to go for what Codlabs Academy, as I was explaining. In Codlabs Academy, I could work with you on continuing your journey, and we will have this kind of meetings every week and teach you the content live, and going from not just like introduction, but I will give you a global path. For instance, you can start learning Python and familiarize yourself with Python, and go again and learn about SQL, which is very, very important, SQL also, and then move on to data analytics. Data analytics is really important to understand how to understand the data before building the model. And then you can go to do some classical machine learning models, as the one we've seen here. Logistic regression is an example. And then you can move on to deep learning. And after moving on to deep learning, you can go to do some advanced stuff with deep learning, such as computer vision and CNNs and stuff. You can also do some natural language processing, and you can try to learn more like different topics. And then when you learn about different topics, as I explained, you can, after that, you can choose, maybe you are more into computer vision stuff, so you can focus on that. Or maybe you are more interested on natural language processing and sentiment analysis and stuff like this, so you can focus on that also, you see. And meanwhile, also focus on always having a technical experience and doing projects. So actually, what I explained is the program that we have in CLA. So this is what we do for our students. Hopefully, I have answered. I've talked a lot. We have another question. So if you want to go deeper on machine learning, we can contact you, right? Yeah, of course. Yes, you can contact me. I will send you my email. Just a second. I will send my email in the chat, so you can send me directly. Just a sec. Okay. So here is my email. You can also send us email over the contact at Codelabs Academy, or you can go to the website. Also, you will find information. So this is all ways to get in touch with us. But yeah, I have sent you my email. You can send me an email there, and I will be happy to reply. All right, Jose. Oh, sure. You're welcome. All right, guys. Do you have other questions? Yes, we have another question. Okay. Is there somewhere a pretty infographic with a pathway? I think there is on the website. Yeah. I think there is on the website. Yeah. Okay. I would try to reach out and share with you. Maybe send me an email. Like, send me an email, or I will send you also, and I'll try to reach out to you and send you our curriculum. Yep. Yeah. Okay. Do you have other questions? Questions about how to learn about machine learning? Questions about what we have done today, maybe, or maybe also what do you want to see next? What is your ideas for the next workshop? Okay, doesn't seem that we have. Oh yeah, we have. Yeah. Yeah. Okay, let's take it one by one. Cybersecurity was mentioned in the meetup. Yeah, actually, we have a cybersecurity program too. If you want to learn about that, we have also some information here. So actually, you can see that we have a front-end development pathway for learning and boot camps. We call them boot camps. And we have a blue teams for cybersecurity also. So we have machine learning, data science, and we have development. We have also UI and UX, and we have cybersecurity. So yeah, you will find more information about about these in the website, and also I can share some. If you send me an email, I can point you to the right people that will help you get to understand more. And actually, we have recently had an info session for cybersecurity program. Yeah. So yep, pretty much yeah. Okay, we have another question. So for the next meetup, I don't know. I'm not sure, but yeah, I think there will be cybersecurity one, yeah. How about machine learning in production environment? Very interesting. Very interesting question. So, people tend to learn about machine learning, but for production, it's another deal. And you won't find like you will learn about how the model works, but you need also to learn how to serve your model. And actually, our in our boot camp, we have a last course over predicting or sorry, predicting over how to deploy your machine learning model. So we will also teach you how to deploy your machine learning model using cloud technologies. So this is also part of our data science bootcamp. Very interesting questions, yeah, because people tend to forget about that. Yeah. Okay. Do you have any other questions? Okay, guys, I think we are at the finish of this workshop. Again, thank you so much for attending from the beginning until now. Hopefully, you have learned something. And I really enjoyed um, talking to you, answering your questions, and understand how you see this fascinating domain that I'm passionate about. So, goodbye, guys. Thank you for being here, and hopefully, see you soon, either with us in CLA or maybe in another free workshop. Thank you, guys. Thank you. Thank you. Bye bye. Goodbye.